So we're moving into section 5.3, which is about exponential functions. So we're going to talk about what an exponential function is. Before we do that, we want to review what a linear function is. So a function is said to be a linear function, or linear, if it may be written in the form f of x, or you could call that f of x, y equals mx plus b. So how can you identify a linear function from its graph? Well, you could see its graph as a line, something like this, right? Or maybe something like this, one of those two. But let's say you just had some points from the function. Let's say we take a table of values, x, y. I'm going to make this horizontal. That's the way you'll often see it in textbooks. You have these two rows. And for my x values, let's say I have -2, -1, 0, 1, and 2. And my y values, think about plugging in, first of all, f of -2. Plugging -2 in for x, you'd have what? M times -2 plus b. That would be basically b minus 2m, right? B minus 2m, if you rewrite that. And you can find f of -1. You have m times -1 plus b. In other words, b minus m. And then I'll have f of 0. It's plugging a 0 for x, so I'd have m times 0 plus b, which is simply b. F of 1, I plug in 1 for x, I have m times 1 plus b. That's going to be b plus m. And f of 2, it's going to be m times 2 plus b, or in other words, b plus 2m. So I'll write those in. So I have, let's see, b minus 2m for my first y. My second y is going to be b minus m. Then I'm going to have b, and then b plus m, and then b plus 2m. Now basically you notice this one here is the y-intercept, right? F of 0 is the y-intercept. So when the x value is 0, the y value is b, so this is the y-intercept. And we know that from our study of lines, right, that the y-intercept is the b. So notice what's happening as you, let's say we start from the rightmost y value. So as you move from the leftmost y value, as you move to the one just right of it, you add m. And then you move to the next one, you add m, and then the next one. So basically you're adding m at each stage as the x progresses from integer to integer. So the x counts up by 1. So as the x counts up by each integer, 1, 1, 1. The y counts up plus m, plus m, plus m, plus m, plus m, plus m, plus m. So there's this constant adding of m at every stage where the integer is increased by 1. That's the idea. You're constantly adding an integer of m, which m is your slope. Okay, so I mean, if you were to actually graph this out, we'll graph a few points out here. This is not to scale or anything, but x-axis and y-axis. So I don't know, we'll just take these points. I'm going to circle in blue here. So you have 0, comma b. So let's say this is b right here, whatever b is, 0, comma b. Now b is just a number on the y-axis somewhere. And we knew that was our y-intercept anyway, right? B was our y-intercept anyway. And then next you'd have, when x is 1, you'd have b plus m. So b plus m, let's say, is here. That would be your next point. So you increase the y value by a positive m, and you increase it by another positive m. This would be b plus 2m. That would be when x is 2. You're going to be at b plus 2m. So, I mean, if you were to connect these all, you get a nice straight line is the idea. Yeah, so the idea is as the x increases by 1, the y is increasing constantly up by m every time. Yeah, so basically we got, what's the slope, right? You're up m over 1, up m over 1. So this is m over 1, m over 1. Okay, so yeah, linear. Now, we want to contrast a linear function to this new type of function we're going to introduce called an exponential. So we haven't talked about exponentials. Not discussed those in this course. So we're going to look at exponential functions and contrast them to linear functions. We want to define exactly what an exponential function is. So here's a definition. A function is said to be exponential if it may be written in the form f of x equals c times ax. And here c should be a positive number, and a should not be 0, and a should be, a should be positive. So a has to be positive, and a cannot be 1. So any function that takes on this form, you have a constant out front, a positive constant, times a number to the x power, that x is a variable, is called an exponential function. So here the key is c is positive, a has to be positive, and it can't be 1. Because sometimes we call a here, this a right here is sometimes called the exponential base. A is sometimes called the exponential base. You'll hear it called that sometimes, the exponential base, a. Okay, so when you hear me use the word exponential base, it's that a number. So let's just look at some examples of some I guess some exponential function. Well, let's look at a generic exponential function. Just in general, let's look at what I want to do. Okay, we're going to use f of x equals c times a to the x. And let's pretend that a is here. So a has to be positive. It could be two possibilities. A could be in between 0 and 1, or a could be bigger than 1, but it can't be 1. Let's just say a is positive and it's bigger than 1. Okay, positive and bigger than 1. So that'd be, say, it's greater than 1. Okay, so I'm going to make a table of values here. It's the way they do it in her book. They make these horizontally. I like to make mine vertically, but they make them horizontally. So let's say we got -2, -1, 0, 1, and 2 for our x values. So if you're finding f at -2, that'd be c times a to the -2 power. Now, maybe you're familiar with the fact that negative exponents can be rewritten as fractions. So basically the idea is that in front of this a to the -2, I'm not even going to think about it that way now. Let's not think about it that way. But basically I'm going to think about a to the -2 here. That allows you to take the a, the negative exponent. What do you do with the negative exponent? It allows you to take the a and put it on bottom of a fraction, put the c on top, and you put a square on bottom that's positive. So you get c over a squared. If I were to write f of -1, that would be c times a, and I'm going to plug in a -1. -1 for my x value in place of the x. So if we're rewriting this, if we focus on a to the -1 here, I'm trying to make that red. There we go. So we're going to leave the c on top, and then a goes to the bottom, and then it just comes to the +1 when you take it to the bottom, or in other words, c over a. If I want to find f of 0, bc times a to the 0 power. Now we know that a to the 0 power is 1, right? Anything to the 0 power is 1, so c times 1 is c. Then we have f of 1 is going to be c times a to the 1 power, which is simply c times a, or you could say ca. And then f of 2, that would be c times a squared, or in other words, ca squared. So writing these in, I have c over a squared, c over a, c, ca, and ca squared. Now let's pretend c's here a positive number. I'll write that. I want to graph this out. X-axis and y-axis. So let's say we have -2, -1, 0, 1, and 2. Okay. So 0, comma c, that's going to be this kind of middle point here. 0, comma c. So let's say c is a positive number. So let's say c somewhere up here. So this is not counting precisely by anything. I'm not making the markings on the y-axis. I'm not going to give 1, 2, 3, and so on. This is your first point, 0, comma c. Now imagine we find 1, comma ca. So ca, let's focus on what ca is. Basically, we're taking c and we're multiplying it by a factor of a, right? c times a, c times a. We're taking c and multiplying it by a. Now, if a is bigger than 1, then that's going to make things a lot taller up. So we're going to multiply things by a factor of a. So maybe that brings it up here. Let's say this is a times c right here. Things get a lot taller. So there we're at 1, comma ac, 1, comma ac. And then let's say we plug in 2 and we get ca squared. Where would ca squared be? Well, if you take ca or ac, yeah, let's call it ac. ac looks better, doesn't it? No, ca looks better. If we multiply that by another a, that's going to make things a lot taller. So this will be ca squared, right? We multiply it up there. This would be 2, comma ca squared. So what's happening is you're getting this. You're getting a curve that increases very rapidly. Now let's go back. Let's look at -1 c divided by a. So what happened if you took c and divided it by a number a that's bigger than 1? Well, that would shrink things down a bit. So c divided by a might be like down here, c divided by a. So -1 c divided by a might be like here. Let me connect that. Now let's say we go back here to -2 for the x value, and then look at ca squared. Well, ca squared, you're going to be dividing c by a squared, which is going to make things even smaller than ca. So ca squared might be like down here. c divided by a squared. So we're down like way here. You connect that. And you keep going. If you keep going, things get closer and closer and closer to this horizontal asymptote right here. So actually we have a horizontal asymptote. I'm going to make this in green. So there's a horizontal asymptote anytime you have an exponential function. At y equals 0. So the x-axis is the line y equals 0. So basically on the left here, as you go to the left, your graph, the graph of your exponential function, is going to get closer and closer and closer to that horizontal asymptote on the left tail, but it's never going to reach. And that's what your graph would look like if here a were sorry, greater than 1, if a were greater than 1. If a were greater than 1. Now, the other possibility you could have is you could have your a value between 0 and 1. So rather than a being like 2 or 3 or 4 or 5, a could be, I don't know, like 1/2 or 1/3 or 1/4. In that case, things are going to be kind of reversed. You're going to be over on the other side. Everything's going to be reversed. And I'll actually demonstrate this a little bit later. So your things are going to, as you move from left to right, your graph is going to decrease. And it's going to go towards the horizontal asymptote. So we'll actually give you some real-life examples of these. So when a is greater than 1, when the exponential base, that's the one I'm circling here in blue. Now let's circle it in red. Let's circle it in red. Make that red. So when the exponential base is greater than 1, you're going to have an increasing exponential function. When the exponential base a is between 0 and 1, like a fraction, then you're going to have a decreasing exponential function as you move from left to right. And you're always going to have a horizontal asymptote at y equals 0. Okay, let's see some actual examples so we can really get a feel for this. Okay, let me just call them examples. Graph the exponential function. So here we have y equals 2 to the x, okay? Y equals 2 to the x. So here my base, a, that's my a is 2, FYI, just so you know. This is the exponential base, it's called. Now, you can actually imagine, if you want, you can actually rewrite this. You could rewrite this as y equals 1 times 2 to the x. So the a, the exponential base, is 2. And the c, that's the number out in front right here. The c is going to be 1. Now, let's make a table of values of this. X's and Y's. They always make these horizontally in our book, so I'll do that. -2, -1, 0, 1, and 2. So I'm going to have, let's see. So I'm going to find, first of all, I'll call this f of -2. That would be 2 to the minus 2 power. In other words, 1 over 2 squared. Yeah, so imagine out front here you have a 1, so you leave the 1 on top. You take this blue part here. Okay, let's use different colors. So I'm going to say there's a 1 out front, okay? So I'm going to leave the 1 on top. I'm going to take this red part I'm circling here, 2 to the -2. I'm going to take that to the bottom and make it 2 to the +2. You change the sign. And that's going to be the same thing as 1/4. Right, 2 squared is 4, so you get 1/4 when you plug in -2. Okay, let's say I wanted to find f of -1. Oh, I would have 2 to the -1. So you can imagine there's a 1 out front, okay? You're going to leave that 1 on top, and you take this here in red, 2 to the -1 on bottom. That's 2 to the 1 now on bottom. When it goes to the bottom, it becomes a positive exponent, so it's going to be the same thing as 1/2. Okay, then I find f of 0. To find f of 0, I'm going to plug in 0 for x. I get 2 to the 0 power. Anything to the 0 power is 1, so it's going to be 1. And I'm going to have f of 1. It's going to be 2 to the 1 power. That's 2. I'm going to find f of 2. It's going to be 2 to the 2 power. That's 4. So I'm going to have 2, 4 for my last point. So I'm graphing these out. getting a picture. Now remember that a typical exponential function has a horizontal asymptote of y equals 0. So we're going to make a horizontal asymptote down here, y equals 0, okay? And I'm going to plot these points. I guess I'll make them all blue. So say we go out to -2 on the left, and on the right out to +2. We're going to do, let's see, 1, 2, 3, 4. Go up to 4 on the y-axis. Let's plot our points in blue, I guess. -2, 1/4 would be back here. -1, 1/2 would be here. 0, 1 would be here. 1, 2 would be here, and 2, 4 would be here. I'll just kind of follow the general shape of an increasing exponential function like that. Make sure you, on the left side, as you go to the left, you approach the horizontal asymptote. As you move to the right, you just get more and more off to positive infinity as you go to the right. The y goes off to positive infinity as you move to the right. It gets really steep. It just grows quickly. Okay? Yeah, so notice that this is one of those increasing exponential functions, and notice that the exponential base that we talked about, right, the exponential base here is bigger than 1, right? It's bigger than 1 here, bigger than 1. So we want to look at another example of an exponential function where the exponential base is not bigger than 1. Let's say it's between 0 and 1. So let's look at 1/2 to the x power, 1/2 to the x power. If you wanted to rewrite this in the standard form for an exponential, you could write this as a y equals 1, right, that's the c there, times 1/2 to the x power. So here the exponential base that's the 1/2, a is equal to 1/2. And the c, that's actually called your y-intercept is 1. The c is always going to be the y-intercept here when you're dealing with just a standard exponential function. This is the y-intercept. I should have said that earlier. This is the y-intercept. Right? C was 1 back here, right? Okay, so let's make a table of values just to get a hang of this. Make them green, I guess. I think I have enough. Get this to right. There it goes. Okay, well, let's find f. Okay, so let's take -2, -1, 0, 1, and 2. Let's find f of -2. F of -2 means we're going to take 1/2 to the -2 power. So basically what we're going to do, when you have a minus exponent, you're going to flip your fraction over. So the fraction is going to become 2/1, and then you're going to make it to the +2 power. So flip the fraction and change the sign. So this is the same thing as 2 squared, which is 4. Then we're going to find f of -1, which is going to take 1/2 to the -1 power. A negative exponent tells you to flip your fraction. So your fraction is going to be 2/1, and you're going to raise that to the +1 power. So basically 2 to the 1 power is 2. Then we're going to find f of 0. So we're going to take 1/2 and raise it to the 0 power. Anything to the 0 power is 1. Okay. What else are we doing? F of 1. Plugging in 1 for x, we're going to get 1/2 to the 1 power is 1/2. And then we're going to take f of 2. 1/2 to the 2nd power is, it's 1/4, right? Think about it. You're going to square the top. You're going to square the bottom. So 1 squared is 1. 2 squared is, why did that write that? I wrote a 2 there. So you square the top, 1 squared, you square the bottom, 2 squared, and you get 1 on top and 4 on bottom. So 1/4. So I got -2, 4, -1, 2, 0, 1, 1, 1/2, 2, 1/4. Okay? So we're going to plot all these out. Let me get rid of this. Make some space. Make some space, and now we're going to graph. So our x's are going to be between -2 and +2, and our y's will go to 0 to 4. Well, it doesn't quite go to 0, but it approaches 0. So let's plot things out. Okay, so I'm starting out with -2, 4, so that would be up here. Then we're going to -1, 2. Then we're going to 0, 1, right? This was our y-intercept, 0, 1. And then we got 1, 1/2, that would be here, and then 2, 1/4, that would be here. So we're going to have this kind of thing going on. This is a decreasing exponential function. So as you move to the right, it's going to be approaching this horizontal asymptote. So we should actually mention this horizontal asymptote. We want to draw that with a dotted line. So we have a horizontal, let's write it down, the horizontal asymptote of y equals 0. Y equals 0 is actually the x-axis. Yeah, and as you move to the left, it's going up towards infinity, the y is. Okay, is there anything else I really want to say here?